When you have an equation with a logarithm equal to a number, there's a few different approaches you could take to try to solve the equation. Suppose we have the equation the logarithm base 8 of x is equal to 4. Let's try changing this equation from logarithmic form to exponential form. The base of the exponential form would be the same as the logarithmic form, 8. Then the answer of the logarithm equation is the exponent of our exponential equation, 4. Here we would have 8 raised to the 4th equals x. Then if we calculate 8 raised to the 4th, it's 4,096. So 4,096 equals x is our solution. This time, let's take a look at a different approach if we have the equation logarithm base 5 of y equals 7. Let's take our base, which is 5, and raise it to both sides. 5 raised to the logarithm base 5 of y is equal to 5 raised to the 7th. On the left side, the exponential base 5 and the logarithm base 5 undo each other, and we're just left with y. On the right side, 5 raised to the 7th gives us 78,125. So that's our solution to the equation. In general, when you're solving logarithmic equations, your first step is going to be to combine logarithms if necessary and then isolate the logarithm. In other words, we want to get a logarithm by itself so that our equation is in the form a logarithm of an expression is equal to a number. Then we're going to use one of the two strategies that we talked about a moment ago. For example, suppose we have the logarithm base 2 of 3x is equal to 10. Let's try changing this equation from logarithmic form to exponential form. In exponential form, the base would still be 2. The answer of the logarithmic equation becomes the exponent of the exponential equation, which is 10. So we would have 2 raised to the 10th is equal to 3x. Now 2 raised to the 10th, it's a big number, but with calculators, big numbers aren't so bad. We have 1,048,576 equals 3x. And then to finish, we divide both sides by 3. And if we wanted to write our answer as a decimal, we would have x is equal to 349,525.3, just to round it off to one decimal place. Let's take a look at another example. Here we have the logarithm base 3 of x plus 2 equals 5. Here, if we change this equation to exponential form, the base stays the same, which is 3. The answer of the logarithm becomes the exponent of the exponential form, 5. And we have 3 raised to the 5th equals x plus 2. 3 raised to the 5th is 243. So 243 equals x plus 2. Then to get x by itself, we subtract 2 from both sides, and 241 equals x gives us our solution. If you would like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. When a logarithm is not written with a specific base, we can assume that the base is 10. So here we have the logarithm base 10 of 4x equals 2. And when we change this equation to exponential form, our base will be 10. The answer of the logarithm becomes the exponent of the exponential form, which is 2. And we have 10 to the second equals 4x. 10 to the second power is 100, so we have 100 equals 4x. Then divide both sides by 4, and we have 25 is equal to x.